Today we are doing the solutions for applied mathematics, CAPE Unit 1, and Unit 1 is mostly statistics. So let's begin right away. Question 1, Part A. A hospital is interested in the average recovery period of patients who have the COVID-19 illness. Identify the term which best defines the following aspects of the study. 1. The set of all persons visiting the doctor. That seems to be the population. So all persons visiting the doctor would represent the population. The patients visiting with COVID-19. So the research is specifically focused on those with the COVID-19. So these patients would constitute the sample. The mean of the population, we refer to that as what we call the population mean or population average, represented by the symbol mu, mu, letter from the Greek alphabet. The mean of the sample, and we refer to this as the sample average. Represented by the symbol x bar. So let's draw the sample mean better. Mu, almost like a U. That's a better illustration. Part B. To create a recreational cricket team, a cricket coach must randomly select 5 players from a group aged 8 to 10, 7 players from a group aged 11 to 12, and 3 players from a group aged 13 to 14. Determine the type of sampling that would be best for this situation. You must give one reason for your answers. Okay, so to create a recreational team, the coach is randomly selecting 5 players from the age group 8 to 10, 7 players from the age group 11 to 12, and 3 players from age group 13 to 14. So obviously the players were divided into what we call subgroups, and the subgroups were divided according to age. So this type of sampling is referred to as what we call stratified sampling. This is what we call stratified sampling. And the reason why it's called stratified sample, the reason is because the students or the players were selected randomly based on what we call stratas or what we call subgroups. In this case, the subgroups were by ages. So stratified sampling because players were selected randomly based on subgroups according to their age. According to age. Let's move on. Part C. The following information shows 31 car prices from a certain company. Draw a box and whisker plot to illustrate the data. So to do a box and whisker plot, we need 5 pieces of information. All right, we need 5 pieces of information. So let's see if the numbers are in ascending order. So 253, 270, 310, and so on. So obviously, these numbers are in what we call ascending order. So we should be able to find the median easily. Now, the 5 pieces of information we need to draw the box and whisker plot. So we need this, the lowest value, and the lowest value there is 253. We need the highest value. So in other words, we need the range, which is the lowest value and the highest value. So lowest value is 253. The highest value is 986. And we also need what we call the quartiles. So we need all the quartiles. So we will need the lowest value, the highest value, and we need the quartiles, and it's 3 quartiles. So what we call, let's find the second quartile first, which is a median. So let's find the Q2, which is also called the median, and the median is the middle number. So you'll notice the question we're told that it's 31 car prices, and to get the middle number, the median number will be the median in terms of the placement of this number is n plus 1 over 2, where n is the number of values here in the data set. It's 31, so 31 plus 1, that's 32. 32 divided by 2 is 16. So the median is not 16. The median is in the 16th position. So the median, no minus 16 position, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the median, or what we call Q2, is 554. We also need the lower quartile, Q1, or refer to as lower quartile, abbreviate at LQ, the lower quartile, and we also need the upper quartile, Q3, abbreviate using UQ. Alright, so the lower quartile, to the lower quartile, since we have an odd amount of number, alright, so the median is 554. So we're going to remove 554 from the data set. So to the left of 554, since it's 31 car prices, so we have 31 number originally in the data set. So we'll move 1, the median, we're left with 30. So to the left of the 554, we have 15 numbers. And to the right of the 554, we have also 15 numbers. So to get the lower quartile, we'll find the median or the middle number to the left of the 554. So the left of the 554, there are 15 numbers. Alright, so the lower quartile, the median of these 15 numbers would be 15 plus 1, which is 16, and 16 divided by 2, 8. So the middle number for the bottom 15 values to the left of 554 will be the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. That's 520. And the upper quartile would be the median for the 15 numbers above the 554. So the middle number above the 554, and it's 15 of them. So it would also be in the 8th position, and that would be 682. Another way of getting a lower quartile, a formula we use is n plus 1 over 4, where n is an amount of values in the data set, 31. 31 plus 1, that's 32, divided by 4, that's 8. So the lower quartile would be the 8th number in the data set, that's 520. And the formula for the upper quartile, which is Q3, is 3 bracket n plus 1 over 4, could have used. N is 31. 31 plus 1, that's 32. 32 divided by 4, that's 8. 3 times 8, that's 24. So the upper quartile will be the 24th number, and the 24th number would have been, so for the lower quartile, that was the 8th number, which is the 520. That's the lower quartile, or Q1. And the upper quartile, this would give us 24. To give us 24, which is the position, which is the 24th number. And the 24th number in the data set is Q3, that's upper quartile. And while already the 16th number, here we have a 16th number, which is Q2, same as the median. So we have all the information we need to do our box and whisker plot. The lowest number, 253, the highest number, 986, and the quartiles. Q1 is 520, Q2, 554, and the Q3, that's 682. So we can do our box and whisker. Let me just do like a sketch here. I say box and whisker, so the whisker here at the end. Alright, and then the box will show the quartiles. Not doing this to scale. So the lowest number should be at 253. The highest number, 986. Q1, that's 520. Q2, that's 554. And Q3, that's 682. That's our box and whisker plot. Let's move on. Determine the prices that would be classified as expensive, considering that a car is expensive if its price is more than 1.5 times the interquartile range above the upper quartile. So that's a mouthful there. So let's read again. The car, determine the prices that would be classified as expensive. A car is expensive if its price, so the price, if it's expensive, if its price, so expensive, let's formulate an expression there, expensive, if the price is equal to more than 1.5 times the interquartile range, 1.5 times interquartile range above the upper quartile. So it's expensive if it's 1.5 times interquartile range above the upper quartile range. So when we multiply the interquartile range by 1.5 and add it to the upper quartile, whatever we get, then any price above that we'll consider that price to be expensive. Now to calculate the interquartile range, we need the upper quartile and the lower quartile. Let's look again what were the upper and lower quartile. Let's go back to here. So the upper quartile was 682 Q3 and the lower quartile was 520. So 682 and 520. So 682 and Q1 was 520, right? Let's write this 6 better. Alright, so the formula for interquartile is Q3 minus Q1. So interquartile would be 682 minus 520. So our interquartile is Q3 minus Q1. The upper quartile is 682. Alright, so that's 1.5 times, no, 682 times 520, so minus 520. 682 minus 520. That's 162 plus 682. This will work out to be now. So 1.5 times 162 plus 682. I'm getting 925. So any car above 925, we will consider that car to be an expensive car. Let's see the prices that were above that value. So the expensive car is prices above 925. So the prices above 925 are these two prices. So these two prices, we consider them to be too expensive. 957 and 986. So the prices, expensive cars would be 957 and 986. These two prices would consider them to be too expensive. State 1, disadvantage of using a box and whisker plot rather than a stem and leaf diagram to represent the data. And there are quite a few disadvantages. One is that the stem and leaf would have all the individual values in the data set. So an advantage could be maybe the data, it doesn't, box and whisker plot does not show the mode. That's one among many. Let's move on. A fitness trainer noted the time spent on a certain exercise equipment in 80 days. The results were as follows. So we're given the results here. The time is in the minutes. So we're asked to copy the cumulative frequency row. So copy and complete. I imagine, complete the cumulative frequency row on the table above. So here's the cumulative frequency row. So it will become the first frequency. Number of days 4. Add 7. We get 11. Add 24 to the 11. We get 35. Add 38 to 35. We get 73. And add 7 to the 73. We end up with 80 as we are expected, because we're told the cumulative amount of days is 80. So we expect to get 80 there. On the grid provided on page 9, draw a cumulative frequency curve to illustrate the data in the table. So cumulative frequency curve. So cumulative frequency will go on the y-axis, and then it goes up to 80, and time will go on the x-axis. Time go up to 75. Let's do the graph quickly. We're not given a scale, so I guess we'll have to choose a suitable scale to end up get 80 on both axes. So here's a graph. So I'm going to do time here, time on the horizontal axis, and time was in the minutes, right? And number of days on the x-axis. So here's 0 where they meet. Let me count by 5. That should take us up to 80. So 5, 10, 15, 20, 25. So we have our axes labeled. So let's plot our point now. So we're plotting the upper boundary, upper limit versus the cumulative frequency. Let's check our table. So here's our table. So there's two first points we're going to plot. So remember, it's time versus cumulative frequency, right? So the first point we're going to plot is 15 to the cumulative frequency 4 and 30, 11. So the two first points, 15, 4 and 30, 11. So 15, 4 will be about there. 30, 11, 30, 11 up, that's a thin line above the 10. So 15, 4, that's 1 point, and 30, 11, that's 2 points. Let's get another 2 points from the table. Another 2 points. 45, 35, and 60, 73. So 45 here, 35, and 60, 73. Maybe about there. And the final point is 75, 80. So we connect our cumulative frequency graph, so we connect all the points as smoothly as possible. Up to the last point, which was 75, 80. So the graph should look something like that. And then let's see if we're asking a question about the graph. So part 2, that's 6 marks for the graph. Part 3, use the cumulative frequency curve to determine the number of days that less than 50 minutes was spent on a certain exercise equipment. So less than 50 minutes. That's what the less than 50 minutes. Let's find 50 minutes. So 50 minutes would be here. Alright, so 50 minutes would be here. So we draw a line from 50 minutes. We draw a line from 50 minutes. And should be a straight line using a ruler. So forgive my freehand. In an exam, of course, students will use a ruler to draw a line, straight line from 50 to touch the curve. And at the point where it touches the curve, then you draw a line horizontally now to touch the days axis. And it's 50. So the answer there would be 50 days. So the solution here would be 50 days. Question 2, part A. State one advantage of each of the following measures of central tendency. So we're asked to state an advantage of the mean, the mode, the median, and there are quite a few advantages for each of them. So for the mean, one advantage is that the mean takes all values into account. Take all values in the data set into account. Another advantage, it's also pretty easy to calculate. The mode, one advantage, quick recognition. You can recognize it, the mode, easily. And another is not affected. It's not affected by extremities or extreme values in the data. The median, again, median is not affected by outliers. Median, as remember, the median is the middle number, so not affected by the outliers. Also, it's not affected by the skewness of the data. Part B. The waist sizes in inches of patients are measured on a particular day at a diabetic screening clinic. The results were summarized in the frequency table below. So we have waist size and we have frequency in the other column. So we're asked to find the mean. So the formula for mean is sum of fx over sum of f. So let's find fx. Now fx, let me find fx. So fx is f times x. So let me do a table for x. And the data is in interval. The waist sizes are in intervals. So x would be just a mid value or the mid interval. And to get the mid interval for each interval, we will average the upper and the lower limit. So we add 27 and 30, divide by 2. So 27 and 30, that's 57 divided by 2, that's 28.5. Add these two values, 30 and 33, that's 63 divided by 2, 31.5. 33 and 36, that's 69 divided by 2, that's 34.5. 36 and 39, that's 75 divided by 2, that's 37.5. And 39 and 42, that's 81 divided by 2, that's 45. So these are mid-intervals, what we call x in the formula. So sum of x, we're going to multiply the frequency. So the frequency is f, right? So f times x, and we sum all the values, all right? So 4 times, let me just bring it further to the right, so I'll have more space. So sum of f(x) so is 4 times 28.5 plus 14 times 31.5 plus 9 times 34.5 plus 7 times 37.5 plus 6 times 40.5. And all of this over the sum of all the frequencies. So the frequencies, so 4 and 14, that's 18, 18 and 9, 27, 27 and 7, that's 34, 34 and 6, that's 40. So all of this divided by 40. If I enter everything in my calculator and divide by, sum the numerator, divide by 40, let's do it one time. And I'll get in, if I'm using one decimal place, it's 34.3 inches. So the mean waist size here is 34.3 inches. So next we're asked to find the mode, and we have a formula for mode. So the mode is the lower boundary plus the class interval times d1 over d1 plus d2. That's one of the formulas, a couple of them, both of them saying the same thing. Now, if we go back to it, let's find the lower boundary. So in the table here, the lower boundary, so the highest frequency is where the mode is at. The mode is 14 is the highest frequency. So the mode is somewhere between 30 and 33. Alright, so the lower boundary, you subtract 0.5 from 30. That's 29.5. So in the formula there, LB representing lower boundary will be 29.5. The class width, now what is it? The upper boundary would be 33.5. Add 0.5 to the number value on the right. So if we take a difference, right, the class width here is 33.5, take away 29.5. So the class width here is 4. Now what's D1 and D2? Now what we call D1. D1 is the difference between the frequency in the row where we have the highest frequency minus, so it's the difference between the frequency in the modal row minus the frequency in the preceding, that's the row before, that's 4. So D1 is 14 take away 4. So in this case, D1 will be 14 take away 4, which is 10. And D2, again, we'll go back to the modal row here, highest frequency, and then the D2 now is difference between the frequency which comes after the highest frequency here, 9. So it's 14 minus 9, and 14 minus 9, that's 5. So again, D1, 14 subtract 4, D2, 14 subtract 9, alright, which is 5. So D1 and D2 are 10 and 5 respectively. So D1 is 10 and D2 is 5. So we calculate that. So the mode is 29.5 plus 4 times 10 over 15. I'll do everything one time in my calculator here. I'll end up with 32.2 inches. The median, again, there's also a formula for the median. Let's write down the median formula. So that's our median formula. So let's fill in the values now. So the only thing we know so far, at least, we know the interval, I, or the class interval, the class width, same, we know it's 4, so we know I is 4. And we know the total number of, in the data set, we know n is total number of patients, we know n is 40. Alright, let's find the rest of information. Cumulative frequency, F, and lower boundary. Let's go back to the table. So, here's the table. Let me just sort the confusion with the while we're finding the mode. Alright, so the median, notice the median is a middle number. So remember we have 40 patients in the data set. So the median would fall between the 20th, so if we add 40, add 40 to the 1 and divide by 2. 41 divided by 2, that's 20.5, which is seen that the median is somewhere between the 20th and the 21st patient. So if you look at the cumulative frequency, by the way, I need to do a cumulative frequency curve column. Let me just do a cumulative frequency column quickly. We'll need to do a cumulative frequency column when calculating the median using the formula there. So cumulative frequency, so we start with first frequency 4, add 14, we get 18, add 9, we get 27, add 7, we get 34, add 6, we get 40. So n is 40, so now there are 40 patients. And the median, as we discussed earlier, is between the 20th and the 21st patient. So notice, if this is for this row, you have 4 patients, another 14, that's 18 patients, and then 27. So the median will be somewhere in this row, somewhere between 33 and 36. So the median row is this row, somewhere between 33 and 36. So the lower boundary here, is subtract 0.5 from the lower limit. So the lower boundary there is 32.5. So in the formula for lower boundary here is 32.5. Alright? The rest of the formula. N is 40. So 40 divided by 2, that's 20. The cumulative frequency is up to the row before the median. So the median row, this is the median row, the 27. So the cumulative, the CF is a value preceding the CF for the median row. So here's the median row. The CF, we're using the CF here to be 18. That's the CF immediately before the median row. So the CF is 18 and F is 9. F is a frequency in the median row, which is 9, but the CF is a frequency preceding the median row, which is 18, sorry. So F is 9 and CF is 18. So we go back to the calculation. So CF is 18, F is 9, and we're multiplying this by 4. Class interval, that's 4. So we end up with 32.5 plus 2 over 9 times 4, 32.5 plus 8 over 9. And that will give us, let's write this on a calculator. And I'm getting, if I'm using the 1 decimal place, 33.4 inches. Continuing, the information on waist size is plotted on the graph below. So on the graph below, in the table, information in the table we just looked at is on the graph here. So we are asked to, what are we asked to do now? We're asked to comment on the shape of the distribution. Obviously, the distribution, we say it's skewed, and we would say it's positively skewed. And the reason we're saying it's positively skewed, notice most of the data is concentrated to the left. Alright, if it was concentrated to the right, we'd say it's negatively skewed. Discuss the skewness of the data based on your estimates of the mean, median, and mode. Let's look at what the mean and mode and median were. So if we remember the question, the mean was 34.3. Mean was 34.3. The median was 33.4. And the mode was smallest. So notice the mean was the largest value, 34.3. So the mean was larger than the median, and the median was larger than the mode. Right? So when you have a situation like that, so the mean was 34.3. Was it? Let's double check. The median is 33.4. And the mode 32.2. So the median, and then the mode was smallest. So notice the mean was greater than the median, and the median was greater than the mode. And when we have a situation like that, we say, if you notice the data again, majority of the data was concentrated to the left, hence the distribution is, again, I'll repeat it here, it's positively skewed. Part C, in an art competition, the number of paintbrushes artists use to paint portraits are examined. The recorded data is as follows. So 11 artists use 1 paintbrush, 10 artists use 2 paintbrushes, and so on. 1 artist use 5 paintbrushes, and so on. Determine each of the following for the given data. So calculate a 10% trimmed mean. So a 10% trimmed mean. So a 10% trimmed mean, we need to find 10% of n. And what's n? N is the number of paintbrushes here. So let's calculate it. So 11 and 10, that's 21, and 5, that's 26, and 3, 29, and 1, 30. So 30 paintbrushes in all. So 10%, which is 10% is 10 over 100, right? Times n, which is 30, So that. Okay, so 1 times 3. So the 10% 3 means 3. And this is telling us that when we're calculating the mean, we're going to remove the first 3 numbers in the data set and the last 3 numbers in the data set. So notice the first, if you think about it, the first 3 numbers, so notice we have 11 ones. So if you should write to the raw data, 1 would appear 11 times. You're moving the first 3 ones. So you're now left with 8 ones. In terms of the final 3 numbers in the data set, the last number was a 5, because 5 appeared once, 5 appeared once. So that would be moved. Now it's 0. And then the next two numbers would be 4s. So if you think about it, the last 5 numbers, based on the information in the table here, the first 11 numbers were 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you have some 2s. You have 10 2s. Then you have 5 3s. Then you have 3 4s. And then you have 1 5. So if you remove the first 3 numbers here, first 3 ones, you're left with 8 ones. And if you remove the final 3 numbers in the data set, you move a 5. So now there are no 5s. And you move 2 4s. So now you're only left with 1 4. So from this new table, now we're going to find the mean. So the 10% trim mean, is equal to, so remember you move 3 from both ends, the first 3 and the last 3 numbers in the data set. So same formula, sum of fx over sum of f. So fx, so that's 1 times 8, that's 8, plus 2 times 10, so this is x, this is f, right? So 1 times 8, that's 8, 2 times 10, that's 20, 3 times 5, that's 15, 4 times 1, that's 4, 5 times 0, that's 0. All over some of the frequencies, 8 and 10. So remember it was 40, and you move 3 and 3, so you end up move 6, so you should have 34. So 8 and 10, that's 18, well, it was 24, sorry, so move 6, you end up with, it was 30, you move 6, you end up with 24. So 8 and 10, that's 18, and 5, 23, and 1, 24. Yeah, so the sum of the frequencies should be 24, since 6 values were removed from the data set. Originally had 30. So divide, so we have 28. So this is what, 19 and 28 divided by 24. And I end up with 1.96. So 1.96. The 40 percentile. Alright, the 40th percentile. And the formula, we have a formula for 40th percentile. Alright, so percentile is formula there is n plus 1 times p over 100 over 100. That's the formula. N, so remember there were 30 values in the data set, so n plus 1, that's 30 plus 1, that's 31. And the percentile, that's 40, so 40 over 100. So that works out to be 31. 40% of 31, that's 12.4. So the 40th percentile with the 12.4, and again 12.4 is just a position. So let's find the actual 40th percentile now. The actual 40th percentile would be in the 12, between the 12th and the 13th position. Alright? So we have 11. So the 12th one will be, so if you think about it, again, I'll do this again, quickly. Percentile. Alright. So if you think about it, 11, the 1 appear 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The next number would be a 2, and it's 10 of them. So 2, 2, 2, 2. And it goes on. 10 twos, alright? But the number between the 12 and the 13 position, alright, would be, so we have 11 ones, then the 12th number, then the 13th number. So the 13th number, between the 12 and the 13 is 2. So the 2 is the 12th number, and a 2 is also the 13th number. So the 40th percentile would be 2 paint brushes. So therefore 40th percentile is 2 paint brushes. Question 3. Differentiate between discrete random variables and continuous random variables. So discrete random variables, so discrete, let me just distinguish between them. Discrete random variables are variables which takes on a finite or countable, whichever word can be used, a countable number or a finite number of possible values. Possible values, while continuous takes on an infinite amount. Alright, so while continuous random variables, let's put RV, abbreviate random variables, takes on an infinite number of possible values. That's the key difference between the two. Alright, so discrete, the number of values are countable. Continuous, the number of values are finite, which means that they are not countable. Let's move to part B. %40 of all tourists who attend a charity event will make a donation. So 40% of those who attend will make a donation. 6 tourists will attend the event, and whether each one makes a donation or not is independent of the other's choices. Let X denote the random variable representing a number among the 6 tourists who will make a donation. State the probability distribution of X and specify its parameter. So this is obviously what we call a binomial. So X is what we call a binomial distribution. Notice there are 2 possible options. Either they donate to charity or they do not donate. And each person, whether they donate or not, is independent of the other person's choices. Alright, so it's a binomial distribution. The parameters, n, number of persons, are we told 6, so 6 persons in total. And the probability that a person will donate is 40%, and that's 40 over 100, 40%, and 40%, that's 0.4, 0.40, same thing. Part 2, calculate the probability that exactly 5 tourists will make a donation. So the formula for the binomial distribution, the probability X equal to K is equal to N C K, and choose K, P to the K bracket 1 minus p to the n minus k. So we are calculating the probability that x equal to 5. So n is the total number of persons who attend, which is 6. So that's 6, choose 5. P is 0.4. 1 minus p is 1 minus 0.4, which is 0.6. N minus k, difference between these two values, 6 take away 5. By the way, k is 5. K is 5. And n minus k is 6 minus 5. That's 1. And we can enter everything in our calculator. And we will end up with 0.03686. Next part, calculate a probability that at least 4 tourists will make a donation. So the probability at least 4 is a probability that x at least 4 means 4 or more. So probability x is greater than or equal to 4. And the probability x is greater than or equal to 4 is the probability x equal to 4. And plus the probability x equal to 5. That was 6 tourists, right? So the maximum number of persons who can donate is 6, since it was 6 persons who attended the event. Now we already calculated the value for, let's put the formula here again, NCK p to the k 1 minus p to the n minus k. I remember n was 6 and p was 0.4. So in doing this calculation, the probability x equal to 4, again using the formula here, so 6 choose 4, p, which is 0.4, to the power of k, and k is 4, 1 minus p, that's 1 minus 0.4, that's 0.6, n minus k, the power here is 2, plus x equal to 5. We already calculated for x equal to 5 already, which was, for x equal to 5, we got 0.03686, so 0.03686, and probability x equal to 6, again using the formula, 6 choose 6, p, which is 0.4, to the power of 6, 1 minus p, that's 1 minus 0.4, that's 0.6, to the power of 6 minus 6, which is 0. So we can enter these in our calculator straight away, and we end up with, for this one, calculator, we end up with 0.13824 plus 0.03686 plus, and this gives us the final one for x equals 6, 0.0041. So we sum all these values, we get 0.1792. So the probability that at least 4 tourists will make a donation is 0.1792. Part 4, at most 1 tourist will not make a donation. So remember, to make a donation was 0.4. So in terms of, if in terms of not making a donation, now p, this time we're using p to be equal to 0.6. Because the probability of making a donation was 40%. So the probability of not making, so this is donation, was 40%. That means the probability of not making a donation would be 60%, represented by 0.6. Alright, so n is still 6, because 6 persons attended the event. So at most 1 tourist will not make a donation, at most 1. So at most 1 is the probability x is, most is 1. So x could be 1 or less. So x is less than or equal to 1. And of course x represent those who will not make a donation. in this case. In the previous ones, X represented those who make a donation. This is X who represents those who will not make donation. And the probability of that happening with one person is 0.6. So the X less than or equal to 1. What are the numbers that are less than or equal to 1 now? 1 or 0. Alright, so using the same formula, NCK P to the K 1 minus P to the N minus K. Same formula, but this time we're using now P to be 0.6, since we're talking about those who did not make a donation. So X equal 1, so that's N choose K, so that's 6 choose 1. P, and P is 0.6 to the power of K, which is 1. In the bracket, 1 minus P, so 1 minus 0.6, that's 0.4 to the power of N minus K, that's 6 minus 1, that's 5. Probability X equals 0. So this time now is 6 choose 0. 0.6 to the power of 0. In the other bracket, 1 minus 0.6, so that's 0.4 to the power of 6 minus 0, which is 6. So the first one, X equal 1, works out to be 0.03686. Probability X equals 0 is 0.0041. And we could have gotten these values, earlier. Because remember, if one person don't make a donation, it's the same thing as saying 5 persons make a donation. And we have already have X equal 5 above there. And the chance of saying 0 makes a donation is 0 do not make a donation, is the same thing as saying 6 made a donation. So if you notice, X equal 1, for here, same as the 5, and same for the 6. Alright, because saying that one person do not make a donation is the same thing as saying 5 persons making a donation. But anyway, so we add these two values, we'll get 0.04096. Part C, the time taken by a secretary to type a 10-page document is normally distributed with a mean of 125 and a standard deviation. Let me just write down what it is. So the mean is 125 minutes with a standard deviation of 5 minutes. Determine the probability that the secretary will take between 118 and 129 minutes to type the 10-page document. So we also calculate the probability that X is between, so X is normally distributed, X is between 129 and 118. So what we need to do now is to standardize these two values using the formula Z equal X minus mu over the standard deviation sigma. So let's standardize these two values, the 129, so calculating the probability Z is between, and I'm going to calculate a standardized score now. So for the 118, to standardize it is 118 X minus the mean, which is 125, over the standard deviation, which is 5. And then to standardize the 129, that's 129 minus the mean, which is 125, over the same standard deviation of 5. So we're calculating the probability that Z is between 118 118 minus 125 divided by 5, that should be a negative number, that's negative 7 divided by 5, That's negative 1.4. And 129 take away 125. That's 4 divided by 5. That's 0.8. So we can use our tables now to get the value. So we'll go to the table and look for 0.8. Let's do that. All right, so we're looking both for 0.8 and for negative 1.4. So here's our Z table. So remember the first Z value was, well, one of the Z value was 0.8. So now when Z is 0.8, when Z is 0.8, here it is, the corresponding probability is 0.7881, and these table gives for less than. So corresponding 0.7 is 0.7881, and for the negative 1.4, so the table does not have negative. So we look for positive 1.4, we look for positive 1.4, and then subtract the value from 1. So for the negative, for when it is negative 1.4, we will, since the table does not have negative Z values, so we'll get, this is for when Z is, this is for when Z is 0.8, and for when Z is negative, equal to negative 1.4, it's 1 minus whatever the table gives you, 0.9192. So it's 1 minus 0.9192, and 1 minus 0.9192, that's 0.08, 0.0808. So 0.7881 minus 0.0808. So our solution here would be, for the 0.8, remember it was 0.7881, minus, and for the negative 1.4, it was 0.0808. So our solution there would be 0.7073. Next, we're told that if the probability that a secretary takes less than T minutes to type a 10-page document is 0.9686, determine the value of T. So remember the normal distribution formula is Z equal X minus mu over sigma. Alright, so we want the Z value for when the probability is 0.9686. So let's go to our table again. We want the Z value for when the probability is 0.9686. Let's check the table again. Alright, so let's look for 0.9686. 0.9686, that's here. And the corresponding Z value, notice the corresponding Z value here is 1.86. So a Z value of 1.86 corresponds with the probability of 0.9686. So our Z value will be 1.86. So we're using 1.86, and the number of minutes T, let's call it XT. The mean, what was the mean again? The mean was 125, standard deviation 5. So the mean was 125 with a standard deviation of 5. So we can solve for T. If I just cross multiply there, that's T minus 125 equal 5 times 1.86. So equal to 5 times 1.86. So T, if I add 125 to both sides, T will be equal to 5 plus 5 times 1.86 plus the 125. Let's group it over here. So T would be 134.3. Remember the unit is minutes, so T is 134.3 minutes. Let's move on to question 4.